Welcome to Fireside on Sarita, and to this, the second in a series of firesides on the topic of the Book of Existence. We talked in the first fireside in this series about what is meant by the idea of a book, that a book, in the final analysis, if you strip away everything else, a book can be written in many languages and appear in many forms, but ultimately it's a body of knowledge. So this idea of looking at the universe in its macro expressions and in its minutest subatomic expressions, and particularly in its expression of living nature as a body of knowledge, a knowledge inscribed into it by a loving creator, knowledge made accessible to everyone, to anyone willing to ponder a while. Look at the world and ponder a while upon it, says Baha'u'llah. It unveileth the book of its own self before thine eyes, and revealeth that which the pen of thy Lord, the fashioner, the all-informed, hath inscribed therein. It will acquaint thee with that which is within it and upon it, and will give thee such clear explanations as to make thee independent of every eloquent expounder. And no one is excluded from this knowledge. It is completely accessible to all. The universe, then, as a body of knowledge, nature as a body of knowledge. So how do we access it? It's there, according to Baha'u'llah. It's right there. How do we access it? And what we're going to look at today is how science, yes, science, can offer a path into the deepest and most profound understandings about ourselves and therefore our Creator, about our Creator and therefore ourselves, about how we can be, how we ought to be, what are our possibilities as communities. All of these answers are available in this fathomless, shoreless sea of knowledge that is right here, right now. And we're going to today look at some great science by Canadian research scientist Dr. Susanne Simard. And Dr. Simard, her work is just so elegant and so elegantly Canadian. I mean, her equipment, much of the equipment she used in her field work, she picked up at Canadian Tire. Now, how Canadian is that? Now, Dr. Simard worked in the forestry industry. And by the way, if you want to hear it from her, rather than secondhand from me, you can watch her TED Talk. And it's titled, easy to remember the title, How Trees Talk to One Another. And she decided that she would leave the forestry industry and educate herself and go back into education. And she began to work on her doctorate. And along the way, she came across a little lab experiment where it was discovered that two saplings in the lab shared their carbon one with another. That became the impetus for her fieldwork in an old-growth BC forest. She thought, well, if that happens in the lab, I wonder what's happening in nature, in a natural setting. Let's find out. And that was her path that opened up before her, and what she discovered is just so remarkable. And you need to understand a little bit of the science. First, you need to remember that photosynthesis is the engine that drives all life on our planet. All of it. Without photosynthesis, there's no life. So what is it? And if you don't know, if you see anything that is green, photosynthesis is happening. If it's a leaf or a pine needle, you have photosynthesis occurring. It is essentially this: sunlight, chlorophyll, water, and carbon dioxide. These are the essential ingredients. Take any one of those away, and there's no life. And where does the carbon dioxide come from? Obviously, it comes from the atmosphere. And we don't realize it, but when we walk into a forest and we see these massive trees and all of the shrubs and weeds and plants and nettles and vines, all of it, the structure of it is carbon. And all of that carbon is drawn out of the atmosphere. But what forms the substance of life is carbon. We are made of carbon. That carbon came from the atmosphere. So photosynthesis then uses the water, breaks it down, because it wants the hydrogen. You know, water is H2O. Hydrogen, one hydrogen and two oxygen atoms. It wants those hydrogen atoms to use in order to make carbon chains. So it breaks down the carbon dioxide. So you have one carbon and two oxygen atoms. So the only byproduct of photosynthesis is oxygen. And trees breathe in, all plants breathe in carbon dioxide, and they breathe out oxygen. And in between, they use the power of the sun, the energy from the sun, to bond together chains of carbon, using the hydrogen atoms to link chains of carbon atoms together. And the energy required to form a bond locks that energy, that sunlight energy. And when those bonds are broken, when they are released, the energy from the sun, the energy that originated from the sun, is released. That's why our bodies are warm. And this process of pulling carbon dioxide out of the atmosphere, creating carbon chains called carbohydrates, sugars essentially, proteins, chains of proteins to make the substance and fiber and fabric of life. This is the process, the engine driven by photosynthesis that is at the base of all life on Earth. Plants, then animals, and so on and so forth, bacteria. And when a tree dies, of course, all of those bonds disintegrate through a process of combustion and interaction with bacteria and so on, digestion. And then all of that carbon dioxide is reformed and sent back out into the atmosphere. So it's a zero sum. And this is why greenhouses inject carbon dioxide into the atmosphere inside the greenhouse to stimulate growth, to accelerate growth. And Dr. Simard went to Canadian Tire. She bought these clear plastic, extra large garbage bags. And her first experiment was simply this. She covered a birch tree, a leafed out birch tree, with this bag, tied it off so that it was airtight. She took an opaque garbage bag and covered over a small fir tree not far from the birch. The reason she used an opaque bag over the small fir tree was because she wanted to interrupt photosynthesis. She wanted to see what would happen between these two trees if one was in need and the other was not. And she had two, I don't know whether you understand what an isotope is, but there's regular carbon and then there are carbon isotopes. And the two she used were carbon-13 isotope, which is a stable isotope, and carbon-14, which is an unstable and radioactive isotope. And she had carbon dioxide that was derived from these two isotopes. So she had carbon-13 carbon dioxide and she had carbon-14 carbon dioxide. And the reason is that you can trace them. It's easy to follow where they go. And she injected carbon-13 isotope carbon dioxide into the bag covering the birch tree. And then she went away. And she came back filled with expectation and wonder, and is this going to work? And sure enough, she ran her Geiger counter up the side of the little fir tree. And there it was, that sound, that hissing, delightful hissing sound. And she knew that the birch tree, because it was performing photosynthesis, shared its carbon with the little fir sitting next to it. And she knew then that she was onto something. And she did hundreds and hundreds of these experiments on full-size trees that very broadly based. And she learned, if we can just sort of cap it or bottom line it, that forests are communities of cooperators. They are super cooperators. They're more about their generosity than stinginess. When another tree is in need, they share. Every tree needs carbon. And in the wintertime, when deciduous trees drop their leaves, they cannot perform photosynthesis. And so they need carbon in order to grow and to thrive. And the coniferous trees around them provide for them. She discovered further that trees recognize their own offspring and support them and withdraw their roots from around them so that they're not competing with their own offspring, to give them a chance to thrive. Wonderful thoughts about the forest. And I hope that you will watch her TED Talk, because it will change how you view forests. You will realize the next time you walk through a forest that you are in a community of friends. So I'm going to just leave it at that. And what we're going to talk about now is how science can offer us windows of insight into the hidden secrets of the universe, the knowledge that is bound up, inscribed in this little scenario, the forest teacher. And we are going to discuss what this says. What does this tell us about ourselves, about our human communities? Another important thing that was discovered by Dr. Simard was that the more diverse, the more complex a forest is, the stronger it is, the more resilient it is, the more resistive it is to harm, to disease. And this, too, is part of the lesson that we're going to discuss in the open forum segment. And hopefully much more. We can talk about forests, and just remember, before we break off, remember that Baha'u'llah refers to us as the trees of the realm of existence. He refers to human beings as trees, not like trees, but the trees of the realm of existence. And Abdu'l-Baha explains that the world phenomenal is like unto the world spiritual. Actually, I think he says it the other way around. The world spiritual is like unto the world phenomenal. and that every thing, every object in the phenomenal world is like an outer picture of the spiritual, of the heavenly world. So everything represents, everything that we see in this universe represents a higher expression in the spiritual realms. So if there are trees here, there are trees in the spiritual realm. The trees here, as beautiful and magnificent as they are, speak about the trees of the realm of existence, among other things. So I'm going to leave it at that. I thank you for your kind attention. I'm looking forward to our discussion.